This is going to be a short demonstration to show how you can collect ground control points with the Reach RS GPS, and you can use EZsurv software to increase the accuracy of those ground points. So essentially there are three ways to get very accurate ground control points. You can use RTK, which requires two GPSs, a rover and a base, and you can place the base at a known point, and then as you move the rover to record your ground control points, they can talk to each other, usually wirelessly, and the rover can compute in real time accurate position because it knows both the base's correction data as well as its own GPS data. You can do RTK by tethering a single GPS to a network of GPSs known as a cores. Your GPS acts as a rover, and the continuously operating reference service acts as a base station. So you have to have an internet connection between your GPS and the cores network. And typically you might do this by tethering through your iPhone, or maybe you have a MySpot, Hotspot, something like that. And the third way to do it is to use a single GPS, log its readings, including its raw data, and then apply the corrections later. So the benefits of post-processing kinematics, i.e. when you do it, when you collect with one GPS and you use that information along with some information you could download of the internet to correct later, some of the benefits are you only have to have one GPS. You don't need an internet connection at the site. So for example, you may have to collect ground control points where there's not a good cell signal. And it's less setup, hassle, it's better, especially on-site, because on-site all you're doing is you're turning your GPS on, you're letting it essentially stabilize for 10 minutes, and then you're walking around, and when there's a point you want to record, you use your control over the GPS to record that ground point. So the equipment I'm using, I have an Reach RS GPS, and I have a GPS pole and sort of a tripod thing that sticks on the pole. I'm using my iPhone to control the Reach RS. At home, I have an iMac running VMware Fusion, which lets me run Windows on my Mac. And I'm using EZsurv software to post-process the data. So the reason I use this is to create ground control points so that when I use photogrammetry software, I can plug them in and both make sure that the photos align more precisely as well as the overall product is better georeferenced. So we're going to do a short demo. I'm going to use the manhole covers around my neighborhood to collect some ground control points. So you can see here's my setup. The Reach is on the top of that yellow pole, and right now it's standing centered over one of the manhole covers in my neighborhood. Note that there are trees all over the place, so I basically live in a forest, and the GPS signal is not great, so we'll see what the results are. Before we get started, I enabled raw UBX logging on the Reach RS, and at each ground control point, so every time I go to a new manhole cover, I'll go to my iPhone, and in the Reach RS application, as you see on the screen, I'll record a survey point, and I'll show you how we use that later with the EZsurv software. So once we collected the ground control point locations with the Reach RS, we'll need to download the survey file. So on the Reach RS, when you are collecting points, those are part of a survey project, and you can download that using your Wi-Fi connection to the Reach RS. I'll typically download that and email it to myself. You also need to download the raw file that the Reach has been collecting, and this file it can be rather big, so sometimes I'll bring my GPS home before I do this. I'll connect it to my Wi-Fi network in my home, and use a web browser on my Mac to download that. Okay, so let's see what this looks like, how you do it. Okay, this is the screen in Windows that I'm running under VMware Fusion. And there's a directory open here. And these are the files that I downloaded from the Reach. So there's a CVS file called demo, and that contains the ground control points that I recorded on the Reach in the survey application. And there's also the raw UBX file, and this contains a continuous record of essentially the GPS signal that the Reach received during this activity. So I'm going to go ahead and launch EZsurv. And it does a little bit of updating when you launch it. And it's pretty simple. All you do is drag that raw file into the observations folder in EZsurv, and it does some initial processing on that file. And then under Tools, you can say Process Auto, and it is identifying a nearby cores network that it can get data from and downloading the appropriate data that it can use to correct the readings you receive from your GPS. So essentially, it collects data that lets it compensate for atmospheric distortion of the signal. In my case, just a few miles away, there's a cores network. And so the distance between me and the cores network is relatively short. And so I should have pretty good correction. In other words, that cores network will experience atmospheric distortion very similar to what I experience. And so it should be able to correct the data pretty well. Although, again, I'm covered by trees, so we'll see how it does. So it takes a little bit to do the processing. This is in real time. Okay, here's a simple report. It's done. You'll notice there were about 8,000 events recorded. That's about 1 a second. And most of them were float, which means they were not very accurate. Okay, so the next thing I'm doing is I am going to pull into the Reach application the file that contains the survey points that I collected. So there's a file called demo CSV. It's the file that was created by the Reach RS. Every time I, in the survey mode, collected a new point or location, it gets added to that file, and I downloaded that file. In EZsurv, you can use those points. Essentially what it's doing is it's giving EZsurv the exact time you recorded the position, and it will go into the continuous raw log along with the corrections that have been applied to it and figure out where you were when you collected that point in the survey mode. So I'm telling it to go ahead and open up that file. It's a text file, and I have to tell EZsurv where to find things in the text file. It's seen this text file before, so it kind of knows where they are, but this is a sample, so you're going to be able to tell it what the delimiter is for the text file, if there are rows to skip because they're the header, that kind of thing. You also have to identify in the next step a column that indicates something like the time you ended collecting that data. So when you're using the Reach and you're in the survey part of the application and you want to record a new point, you hit record new point, and it starts collecting data, and you can tell it when you're finished. So essentially, it's collecting satellite data to refine where the position is, and finally you say, I accept that position, and it takes all the information it had up to that point to make its best guess. So you have to tell the EZsurv software where in that text file you ended the collection. In other words, ultimately, I want to know where the GPS was when it ended collecting for each of these points. So it goes along here. And I'm going to go ahead and tell it OK. And bingo, it's now created a CVS file, actually two files, a header file that tells you some information about how this was created. So it tells me the base or the cores was 2.9 kilometers away, so forth. And then it creates a file, it calls an event file, and each line in this file represents the corrected position of one of the ground points I collected. So these are your ground control points in text format. Now, so let's see how we did. So this is a Google Earth snapshot of two of the manhole covers in my neighborhood. And the red mark is the uncorrected position. And if you notice on the upper left-hand corner, it's about 5 feet away from the center of the manhole cover, and it's displaced from that mostly south. And if you look at the right lower corner, the red is about 3 feet away from the center manhole cover, and it's displaced north. So not only are the uncorrected positions wrong, but they vary differently, so they're not consistent. The little green dots are the corrected positions, and they look to be about a foot west of the location, but they're displaced the same. Now remember, I captured this stuff in a wooded area, and the application indicated that most of the points I collected were not fixed, so they were a little less precise. However, it turns out that these points are displaced from the center of the manhole cover pretty much identically throughout the neighborhood. I'm not going to pull up all the pictures, but it did a really good job. And in photogrammetry, you want two things. You want absolute accuracy, and that helps the total product be correctly georeferenced so that you can overlay one image on another or on other features. But in addition to that, you can have a little bit of error in the absolute accuracy. But if the error is consistent, those ground control points aid the photogrammetry software in stitching the photos together. So in this case, this is perfectly acceptable. It means that the overall model of the neighborhoods, I've done this before, the neighborhood's about 20 or 30 acres, might be shifted a foot in absolute terms, and I can fix that. I can shift that foot. But more importantly, these points are in the same place. And so I know that the registration among the images will be correct. So that's pretty much all there is. It's easy to use. Hopefully this was helpful.